Hey Tigers, we are talking about page 44 of your notes today. We are going over solving equations when there are variables on both sides of the equal sign. All right guys, our essential question today is how can you represent and solve equations with variables on both sides? All right, so we have no vocab terms today. And really guys, we're just going to start with a review of solving two-step equations because really the skills are the same for what we're going to be doing today. All right, so as a reminder, when you guys are doing problems, meaning you have all the pieces and you just need to know the final answer, you guys do PEMDAS. You go PEMDAS ordered, okay? So that's when you guys need to solve for an answer or a total. But when you guys have a variable, we're actually undoing PEMDAS because we have to find a missing piece, okay? So if you're looking for an answer or a total, you're doing PEMDAS. And then if you guys are looking for a variable, you guys are undoing PEMDAS. So you start at the bottom. All right, so let's just do an example problem here. So we've got 2x minus 5 equals 9. Okay, according to reverse PEMDAS, because we've already got our answer or total, what we don't have is the variable. So since we're solving for a variable, we're undoing PEMDAS. So we're going to start at the bottom with addition and subtraction. I do have a subtraction to get rid of, so I'll do addition to get rid of it. Remember, rule 2, if you do it on one side, got to do it on both. These go away. We're left with 2x. 9 plus 5 is 14. Okay, there's no other addition or subtraction to do. So now I can move up to multiplication or division. There is a multiply by 2, because remember, a number right next to a variable means multiply. So the opposite of multiply is divide. So I'm going to divide by 2. And again, if I do it on one side, got to do it to the other side. Those go away. I'm left with x. 14 divided by 2 is 7. Okay, so that's just our review of two-step equations, okay? And you guys can actually turn back in your notes if you want a more in-depth review of that. You guys can turn back to page 16 of your notes. All right, so now we're going to go into solving equations when there are variables on both sides, okay? So step 1 is we are going to use inverse operations to move all the variables to the same side. Now, it doesn't matter what side you guys choose to move them to. Personally, I always move them to the left because I like to have my answer be the variable equals the number, but it doesn't matter. You guys can move it to whatever side you want. Okay, so using inverse operations, okay, two sides. I'm going to move my 7x over here because, again, I like to have the x's on the left, but that is up to you. So the only way to get rid of 7x is to subtract 7x. That's how we get it to move to the other side. Okay, 3x minus 7x gives me negative 4x minus 26 equals 2 minus 4. Okay, step 2, I'm going to use inverse operations to move all the constants to the other side. So whichever side you picked for the variable, move the constants, or the numbers that don't have variables, to the other side. So since I moved my variables to the left, I'm going to move my constant to the other side. Okay, so I've got negative 4x equals 2 minus 4 plus 26. Step 3, combine all like terms on each side. And you guys can do step 3 as step 3, or you could actually do it before step 1 if you want to do that. Okay, it doesn't matter when you do that as long as it happens. So obviously negative 4x is still just going to be negative 4x. 2 minus 4 is negative 2. Negative 2 plus 26 is going to be 24. Okay, now I'm back to a one-step equation. I'm going to use multiplication or division to solve for the variable. Since I see multiplication, I'm going to do division. And since I want to get rid of the negative as well as the 4, I have to divide by negative 4. And that leaves me with x equals -6. Okay. So guys, I am going to show you another way that you guys could do this. It's called the box method. Some people find this a lot, they think it makes a lot more sense, but it is kind of up to you guys which one you choose. You don't have to do one way or the other. I know that in previous years, people have really, if this is not making sense to you, this makes a little bit more sense. So just choose whichever one works for you. Okay. So for the box method, what you're going to do is box all the variable terms and circle all the constant terms. So 100 is a constant, -6x is a variable, 160 is a constant, and -10x is a variable. Okay, so there, boxed and I've circled. All right, step 2, boxes all go on the left side and circles all go on the right side. If a term, there should be a period there. If a term switch sides, change it to its opposite. So it's got to be positive or negative. So I'll leave my equal sign here. Okay, so I know 160 is going to stay here. And 100 is also going to go over here. But 100 was positive over here. Since it's changing sides, I have to say -100. Okay. -6 is going to stay here, or -6x is going to stay here. And then -10x is going to move to the other side. But since it moved to the other side, instead of negative, it's going to be positive. Okay, now we're going to combine all of our like terms. -6x plus 10x gives us 4x. And 160 minus 100 gives us 60. And now, step 4, we're just going to use division because we see multiplication. So divide by 4, divide by 4. That gives us x equals 15. Okay, either method is perfectly okay, guys. It's just whatever makes sense to you guys. All right, if you have any questions, please put them in the Your Question column. It's a real big column today because there's no vocab. And then at the bottom here, please take a look at the summary question. What is a real-world situation that could be represented by the second example equation? So look at this example. Try to come up with a real-world situation that this makes sense for. Okay, we will talk about that in class.